Then there are some biologists who are usually mathematicians who've converted to being biologists, and they think that if anything exists, it must be mathematical. As mathematicians always think that, well, most of them think mathematics is more real than nature, that somehow there's a world of mathematical truth which is reflected in the physical world. So they think the job is to find equations to describe these fields. I think equations are useful, these mathematical structures are useful models. I personally am not a Platonist. I don't think that mathematics is more real than the world we live in, although many mathematicians do. One of the problems with this mathematical Platonic approach is that Platonic forms don't evolve. Eternal mathematical structures are eternal, they don't change. Yet living organisms do, they evolve. This is the most fundamental feature of biology, that it evolves, that life evolves. So if these fields govern living things, since the living things themselves evolve, the fields must evolve too. So how could a field evolve? We're not used to the idea of fields evolving in physics. Most people assume that electromagnetic fields have always been the same, or gravitational fields. Although now, in superstring theory, in the most advanced regions of modern physics, people are at last speaking about the evolution of the fields of nature. But physicists would expect this evolution of fields to happen in the first few microseconds of the history of the universe, and after that they stay more or less the same. But nevertheless, they're admitting the principle that fields evolve, which is important because it's beginning to put physics onto an evolutionary basis. Anyway, if these biological fields evolve, then how would the history be within the field? And this is the key part of my hypothesis, that the fields have a memory within them. I think that the fields of a jaguar, for example, depend on the actual form of previous jaguars, that each member of a species draws on the memory of those that have gone before. The fields contain a kind of collective memory. It's as if the forms of all previous jaguars are sort of superimposed in the morphic field of a new jaguar. Since all previous animals are slightly different, the field is given by a probability distribution, not a sharply defined jaguar outline, but it's like a probability structure. And this is what quantum fields are in quantum physics. They're probability structures. I think these fields are rather like quantum fields. They're structures of probability that influence what will happen in the developing organism by altering the probabilities of chaotic or otherwise indeterminate processes. At every level in nature there's a spontaneity and a freedom which is not fully determined, and the morphic fields working from the next level above restrict the possibilities. They make one thing happen rather than another, and they work by modifying probabilities. So I think the fields have a probabilistic, they have an inherent memory, and therefore they evolve. And the process whereby a jaguar relates to the forms of previous jaguars I call morphic resonance, the influence of similar things on subsequent similar things across space and time. So the morphic fields within and around an organism take up their shape depending on what's happened in similar organisms in the past. Morphic resonance is a non-local connection. It involves a connection through space or time, where the information, the pattern, moves, but not energy. It doesn't involve a transfer of energy, but of information, of form.
Sorry, it's just between the species?
It's usually, the basis is similarity. So the more similar, the stronger the influence. So in the case of mammals, for example, all of them are similar when they're very little, although embryonic mammals are very similar. We're not very different from a rat or a dog when we're very small. I think at that level, probably all mammal morphic resonance in the early embryo, there's a big influence from many different species, and as the embryo develops, it becomes more different, and it becomes more specific, the resonance. And the resonance is always from the most similar things in the past. So the greatest resonance working on all of us will be from past members of our own family, from those who are most similar to us. In the case of dogs, as they develop, a Labrador would be mostly influenced by Labradors, and it would tend to have the behavior of Labradors and a sheepdog of sheepdogs, and because they're more similar. But there would still be a more general resonance from all other dogs, so there would be a general dog characteristic with more specific influence of the particular breed. So, and among human beings, the ones that are most similar are identical twins. So I would think you get most morphic resonance between identical twins. If they're separated at birth and live in different countries, still their great genetic similarity and their similarity of environment in the womb would mean they resonate very strongly with each other. And I think that's why we often find identical twins one may have particular mannerisms, take up a particular job, marry a woman with a particular name even. And many studies on identical twins, mainly at the University of Minnesota in the United States, have shown extraordinary similarities between their development. Usually this is interpreted to say, well, all this must be genetically programmed. But I don't think that's what's happening. I think most of it is because they resonate with each other most specifically. So morphic resonance is based on similarity. And in the case of development, this is related to genetic similarity. Genes, of course, play a part in all this, but it's as if the genes create the components of the television set. If you have a television set, you have to have the material structure of the set. You have to have the right transistors and wires and condensers and all that for the set to work. The genes give rise to the material structures. But the pictures you see on the screen of the television set, for example, as people see us on the screen, if they didn't know anything about television, they might think that small versions of us, that we were actually inside the set. But we're not inside the set. We can tell everyone that definitely. We're not inside your television set. We're somewhere else. We're in Buenos Aires. And so the influence, the invisible influence, is coming into the television set from outside through a field. And this is then appearing on the screen. If you change the material components, the picture will change. Take out a condenser or resistance from the tuning circuit and they may get some other channel. If you change another one and the picture may lose its color. These would be like mutations where genes change in living organisms. They can affect the form, they can affect what happens, but it doesn't prove it's all coming from inside the television set. You see, I think the mistake in contemporary biology is to assume it's all arising from inside, that everything must be explained by the genes and the proteins that are in the material structure of the organism, whereas in fact a great deal of what's happening depends on invisible influences coming from outside, from other organisms, through morphic resonance. That's why I think we need these invisible fields to help explain organisms and influences by morphic resonance from other places and other times. Otherwise it's like you could spend years trying to understand a TV set, just analyzing copper wires and analyzing. You could spend many years and you'd never understand how it really works. And I think that's what modern molecular biology is doing. There's plenty of work to keep people going. There's so many enzymes, so many DNA sequences. There's enough work here to keep people going for decades. They'll all be busy, they can publish papers, there'll be conferences and more discoveries and so on, patenting genes. But it will never lead to an understanding because it's not all inside the organism. The influences are coming from outside as well. So I think that's why we need to have both the fields and the genes to understand heredity, and why the understanding of life has to involve more than just the structures inside the organism. I've spoken mainly about the development of form, but the same principles apply to the evolution of behavior, because the nervous system is very indeterminate, and I think that there are patterns of activity imposed on the brain through these fields which control, and they work on the brain. The brain's like an instrument that these fields can play on. It's a very crude analogy. It's like a piano on which the fields play. You can have a piano, it can play many different sounds, but the pattern of movements depends on the music that's being played, and that's not contained inside the piano. If it's a jazz pianist, in his own mind, he can make up these things as he goes along. You'd never find the pattern of the music by analyzing the strings of the piano.
But that's a fabulous point, I believe, because it questions, it's that, like, the information coming from outside, no? And that's all a great difference. No?
That's a big difference from the usual view, which would always say it's coming from inside the brain or inside the genes. So the whole of our modern biology is based on the idea it's all inside. But we now have so many technologies, so many metaphors, which can show us it's not all inside. The whole modern world is based on electromagnetic technologies. Every room that we're in, every space we're in, is full of invisible influences coming from mobile telephones, radio transmissions, TV transmissions, and so on. There's a huge amount of invisible information. 100 years ago, this was inconceivable. Now, it's part of everyday life. Every child knows that there's invisible information everywhere. We take it for granted. And it's a strange thing, you see, that the main ideas within mechanistic biology were formed in the 19th century. In fact, the machine theory of life was developed in the 17th century by René Descartes. And in a sense, this is locked into a conceptual framework, which is no longer appropriate. It's based on a kind of old-fashioned materialism, that only the matter inside the organism is important, leaving out of account the fact that non-local fields, invisible connections, are actually the way that most of nature, even according to modern physics, works. And so I think that in biology too, a lot of the information in the organism is coming from outside, not just from inside.
Yeah, very interesting. And